everybody, we're going to look at our morning work. This is going to be for April 27th through May the 1st, okay? So Monday number 1 says Sonia and Phil are making costumes. Sonia's costume needs 3 2/3 yards of fabric. Phil's costume needs 6 7/12 yards of fabric. How much more fabric does Phil need than Sonia? So hopefully you saw that and realized that it is a subtraction problem with fractions. So to subtract fractions, I'm going to use the 4 square method. And it tells me in the problem that Phil needs more fabric. So I'm going to put his first. So he needs 6 7/12 yards. And we're going to find the difference between that and 3 2/3 yards. Okay, so remember with the 4 square method, we're going to list the multiples in this second section. We're looking at the multiples of the denominators. So I have 12 and I have 3. I'm going to count by 12s and then I'm going to count by 3s. You should quickly realize that 3 actually will go into 12. So 3 plus 3 plus 3 plus 3 is going to be 12. So my common denominator is actually going to be 12. So at the bottom I have 6 and then 7/12 can just stay the exact same. And then I'm going to subtract 3 and something. And I know that 3 times 4 equals 12. So I have 12 here, and whatever I do to the denominator, I need to do the same thing to the numerator. So if I multiply it by 4, I'm going to also multiply my numerator times 4 as well, and 2 times 4 is 8. So then you get into a weird situation with this problem, where if I'm going to subtract, I would start with the whole numbers, and that's going to be fine. But then when I try to subtract my numerators, the first one is smaller than the second one. And if I say 7 minus 8, I'm going to have a negative numerator. And I don't want any negatives in this problem because this first amount is larger. There shouldn't be a negative. So we looked at a couple ways in class to do this. But one way that you can solve this problem is I can borrow a whole number here. So I'm going to actually take away a whole, which is 12/12. That's one whole. So now instead of 6, I have 5. And I'm going to add those 12/12 over to my fraction piece. Okay, so I'm just adding 12/12 plus the 7/12 that are already there. And 12 plus 7 is 19. So this is going to become 5 19/12 minus 3 8/12. We talked in class about another way to do that. You could actually convert both of your fractions to improper fractions by multiplying and adding, and then you could subtract that way. This is just another way to look at it, okay? So now I have 5 minus 3, which is 2, 19 minus 8, which is 11, and then my 12, my denominator is going to stay the same. Okay, so my final answer is 2 11/12. That's how much more fabric Phil needs for his costume than Sonia. Number 2 for Monday says Josh and Anna each had a candy bar. Josh's candy bar has 24 pieces. And he ate 2/3 of the pieces. So I just drew a candy bar with 24 pieces to solve this problem. And I know that he's going to eat 2/3, so I definitely want thirds to be in there somewhere. So if I split it like this, I'll have 3 sections. But there's 24 pieces, so that would be 8, 16, 24. So I need to split it horizontally into 8s. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 8, 16, 24. Now, Josh ate 2/3 of the pieces. So I have 3 sections. If he eats 2 of those sections, I have 8 plus 8, or basically Josh ate 16 pieces. Okay? Then it's very similar for Anna. It says Anna's candy bar also had 24 pieces. but she ate 3/4 of her pieces. So I know I want to have fourths, so I'm actually going to split it like this, but she still has 24. So if I have 4 sections, 24 divided by 4 is 6. I know I need to have 6 sections horizontally. Okay, so now I have 1, 2, 3, 4, 5, 6, 12, 18, 24. So here's her candy bar, 24 pieces. She ate 3/4 of those pieces. Okay, so if this is a fourth, this is a fourth, and this is a fourth, and I had 6 in each section, so I have 6, 12, 18. So she ate 18 pieces. And then you can look at your answer choices and really see which one is the correct answer. And of course they're going to try to trick you because A and B are pretty much flip-flopped. A says Josh ate 1 more piece. B is Anna ate 1 more piece. C and D are also flip-flopped. So be careful. A mistake that I've seen in the past is that people will get everything right with the numbers and they forgot which one was Josh and which was Anna. Maybe they didn't label, or maybe they were just in a hurry and they accidentally said that Josh ate 2 more pieces than Anna, which is incorrect. So be really careful with that. Now, if we wanted to solve that problem with an algorithm instead of a picture, which is the way that some of you may have done it, it says, sorry, I can't decide what color I want. Okay, so Josh had 24 pieces and he ate 2/3 of those pieces. And we know that if it's a fraction of another amount, that's the same thing as multiplication. Okay, so we're actually going to be multiplying, and to make this a fraction, I would just put it over 1. So 2 times 24 is 48, and 3 times 1 is 3, and I know that the fraction bar means to divide, so 48 divided by 3 is going to give you 16, or the same answer that we got with the picture. Same thing for Anna. Her candy bar has 24 pieces, but she ate 3/4 of 24 pieces. So 3/4 of 24 would be 3/4 times 24 over 1. And then we could multiply. Okay, so 24 times 3, well, I know that 3 times 4 is 12. 3 times 2 is 6 plus 1 is 7, or you may have done that in your head and counted by groups of 20 and then by groups of 4. And then 4 times 1 is 4. And my fraction bar means to divide, so 72 divided by 4 is 18. Okay, either way you'll get the same answer, but that's just 2 different ways to solve the same problem. Tuesday number 1, Tina walked around a 2.5-mile track 3.5 times. How many miles did she walk? Okay, so she walked around a track that's this big, and she walked around it 3.5 times. So we're going to multiply. You could have used decimals to solve this problem. So for example, you might have said 2.5 is the same as 2 5/10, and 3.5 is the same as 3 5/10, and then you could get your answer that way. If we are solving it with the fractions that we're given, I know that when I multiply mixed numbers, I need to first turn my mixed numbers into improper fractions. We talked about in class the loopy method, where you could say 2 times 3, 2 times 1/2, 1/2 times 3, 1/2 times 1/2, and add those partial products. But another way to do it is to turn both fractions that are mixed into improper fractions. So I'm going to say 2 times 2, which is 4, and then I'm going to add the 1, which is 5, and put it all back over 2. So I really have 5 halves. Okay, and then the same thing over here. 2 times 3 is 6, and 6 plus 1 is 7, and then I'm going to put it all back over 2. So I have 7 halves, and then I'm going to multiply. 5 times 7 straight across is 35. 2 times 2 is 4. And then you could turn that answer back into a mixed number. I can't remember on the quiz if I put a mixed or an improper. I think I put both, actually. But to turn this into a mixed number, I would just divide, because fraction bar means to divide. So I would say 35 divided by 4. Tuesday number 2. this is probably the trickiest problem on this whole assignment in my opinion. Jeremy used a total of 1/2 gallons of gasoline to mow 3 lawns that were all the same size. Let G represent the amount of gas in gallons used for each lawn. Which equation is correct? And then it's not actually having you solve. You just have to find the equation that matches it, which sometimes is more of a challenge than just solving the problem and finding one answer. Okay, so he has a tank of gas or a gallon of gas, but he does not have the whole thing. He's got 1/2 of a gallon left. All right, now he's going to use this to mow 3 lawns that were all the same size. So I would split this into 3 sections. Okay, and then it says let G represent the amount of gas for each lawn. So this would be 1 and then G and then G. So he's going to use this much for one lawn and this much for another and this much for another. Now, you should already be thinking, oh my gosh, Miss Dowell-Young, this is not a correct picture because if I'm going to split this, I need to split this empty part up here. Even though it's empty, I want all my pieces the same size if I'm dealing with fractions. So it's not fair to say that G represents 1/4. There are 4 pieces, but this is a drastically bigger piece than the others. So I need to split them to be the same size pieces, okay? So now G, 1 lawn or 1 yard, pretty much equals 1 out of 6 equal pieces, or 1/6. Now, if you were just solving the problem, you're like, okay, the answer is 1/6, I'm good to go. But of course, they're gonna make it more tricky because 1/6 is not an answer choice. But what you're finding, it says let G represent the amount of gas for each lawn or each yard. So we know that G equals 1/6. So one way you can solve this problem is you can go through A, B, C, and D, and everywhere there's a G, you could plug in 1/6 to see if it equals what it says it does. For example, A says G times 1/2 equals 3. So if I replace G with 1/6, because I know that that's the answer, if I replace G with 1/6 and then I solve the problem, if that was the correct answer, it would equal 3. Okay, 1 times 1 is 1, 6 times 2 is 12. 1/12 is not the same thing as 3 wholes. So that tells me that A is incorrect. So that's one way you could solve this problem. The way that they're looking at it, at first you might say, okay, well, if I want to find G, I basically took 1/2 of a tank and I split that 1/2 into 3 pieces. Now really I split the whole can into 6 pieces, but just that 1/2 was split between 3 yards that he was going to mow, and my answer was 1/6, or G was my answer, okay? So I'm going to replace this with G. But that is also not an answer choice. Even though this is correct, that's not one of our multiple choice answer choices. So remember that the opposite of division is multiplication. So if 1/2 divided by 3 equals G, well then G times 3 equals 1/2. And I believe that's an answer choice. Yes, that is answer choice B. So this one, in my opinion, was the trickiest problem on this whole sheet, just because it's easy maybe to find the answer, but then finding the answer choice is a little bit trickier. Okay, Wednesday number 1 says each cookie in a box has the same weight. The total weight of 5 cookies is 1/10 kilograms. What is the weight in kilograms of 1 cookie? This is probably the second trickiest problem that I've seen people make simple mistakes in the past, and we all make mistakes, so I'm not putting anybody down. Okay, here's my box of cookies. Beautiful. Okay, each cookie in a box has the same weight. The total weight of 5 cookies is 1/10 kilograms. So I have 5 cookies, and the total weight is 1/10 kilogram. Okay? Now, it says, what is the weight of one cookie? One cookie. One of these cookies is not going to weigh more than 1/10 kilograms. Okay? The whole box equals 1/10. And that's the mistake I've seen people make, not even in this class. I haven't seen your answers yet, but in previous classes, and even when I've solved the problem sometimes, there's a simple mistake that can be made. You have to look at your answer and see if your answer makes any sense, okay? That's going to help you with little mistakes. So what we're doing is we're taking 1/10 for the whole box, and that is split between 5 cookies. So I want to find the weight of just one. So I want to take this 1/10 and I want to split it between the 5 cookies because my question says, what is the weight of one cookie? When I multiply with fractions, first of all, I'm going to make this a fraction. When I multiply with fractions, I use keep, change, flip. Keep, change, flip. So 1/10 is going to stay the same, or I'm going to keep it. Change, this is going to become multiplication, and then flip, this is going to become 1/5, 1/5. 1 times 1 is 1, 10 times 5 is 50. So each cookie weighs 1/50. 1/10 is a lot bigger than 1/50. 1/50 means I took something and I cut it into 50 pieces versus I took something and cut it into 10 pieces. Those pieces are going to be larger. So the answer is 1/50 kilograms. Now, I have seen where people accidentally either multiplied, maybe they said 1/10 times 5, which would be 5/10 or half. That's still bigger than 1/10. I've also seen people do something to where they basically get 50, and you may have gotten 50 as your answer. Like maybe you said 5 divided by 1/10 and then used keep, change, flip and got 50, which is easy to do, and you probably, if you did this, you at least got the operation, you at least worked it out correctly. 5 divided by 1/10 is 50. But then if you think about the question, it says, how much does each cookie weigh? My goodness, a cookie is not going to weigh 50 grams when the whole box only weighs 1/10 of a gram, or kilogram. So please be careful, please be careful. The answer is 1/50 kilograms. Wednesday number 2, Brenda worked on some of her assigned math problems at school, but she still had 2/3 of the problems to work on at home. Before dinner, she did 3/4 of the remaining problems. What fraction of the whole assignment did Brenda work on at home before dinner? Okay, I also think of this with a picture. Okay, so she worked on some at school, but she got home and she still had 2/3 of her problems left to do. So I'm just going to split it into thirds, and I'm going to say she had 2/3 left to do, okay? Before dinner, she did 3/4 of the remaining problems. So we could split this into fourths, or I could also think of it with an algorithm. She did 3/4 of the 2/3 that were left, okay? So I'm going to be multiplying because of means I'm going to multiply. So if we do that, 3 times 2 is 6, and 4 times 3 is 12, and then if we simplify, we would get 1/2. So she still had, she worked on 1/2 of the assignment before dinner. Thursday number 1 says, The Jones family went on vacation. They left 3 bowls of food for their cats. Each bowl holds 3 cups of food. Okay, so let me represent that. So they have 3 bowls. Okay, each bowl holds 3 cups. So I could either draw 3 cups, or I'm just going to put 3 C's. They used a scoop that holds 1/4 cup. So how many scoops did it take to fill all the bowls? So each scoop is 1/4 cup. That means it's going to take 4 scoops just to equal a cup. And then 4, and then 4, and 4, 4, 4, 4, 4, 4. I could add all of that up, or I could say we have 9 cups, and we're seeing how many 1/4 cups it takes to fill it up. So we could say 9 divided by 1/4. And then if I use keep, change, flip, 9 times 4 is 36, and 1 times 1 is 1, but 36 divided by 1 is just 36. Okay, it should be the same thing if you said 4 plus 4 plus 4, and then multiplied or added that. Last one, number 2 for Thursday. The area of a garden, it says find the area of the garden in square feet, and then it has 5 2/3 and 12. So to find the area, I'm going to multiply length times width. So I'm going to say 5 2/3 times 12. And again, whenever I multiply a mixed number, I first need to make it an improper fraction. So to do that, I would say 5 times 3, which is 15, and then plus 2, which is 17. That all goes back over 3. And then 12 over 1 is going to stay the same. So let me just rewrite this to save room. Okay, so I have 17/3 times 12 over 1. And when I multiply, I'm just going to go straight across. So I'm going to start with 3 times 1. That equals 3. And then 17 times 12. You could use area model. You could use the lattice method. Actually, I think I used the area model when I was doing this in my notes, but I'm going to use standard for right now. 2 times 7 is 14. 2 times 1 is 2. And then I have 3. 1 times 7 is 7. 1 times 1 is 1. Okay. So I get 204 over 3. Now that is not an answer choice that I've given you because I really want to drill into your head. That sounds painful, sorry. I really want you to realize that the fraction bar means to divide. So this really means 204 divided by 3. Okay, and I know that it's going to equal out evenly. There's not going to be a remainder because 2 plus 4 is 6, and 6 is divisible by 3 without a remainder. Okay, so 3 goes into 20 6 times. 3 times 6 is 18. I subtract and get 2. Bring down the 4. 3 goes into 24 8 times, and 3 times 8 is 24. So your final answer is 68, and it was the area, so it's going to be 68 feet squared, or 68 feet to the second power.